So today I want to talk a little bit about the supporting cells and the supporting glands of the male reproductive system. So this will be the seminal vesicles, the prostate gland, the bulbourethral gland or Cowper's gland, Leydig cells, Sertoli cells, and some hormones that are involved in the male reproductive cycle. So first, let's go over the seminal vesicles. The seminal vesicles are about 5 centimeters or 2 inches in length or in size. So for most people, that's about the size of their pinky finger. This is a paired gland, and the glands sit at the base of the bladder where they connect to the vas deferens. We'll see where the vas deferens where those connect with the prostatic urethra to become the membranous urethra later. The seminal vesicles are responsible for about 50 or 60% of semen, what semen is made up of, and it's going to be only about 5% of semen is sperm, and everything else is other fluids. So the seminal vesicles are going to help add nutrients to the sperm, so the sperm can survive longer in the female reproductive tract. So we also know that sperm can last for about 3 to 5 days in the female reproductive tract, and that is what helps them to survive that long. Additionally, seminal vesicles add fibrinogen to semen, and so this is going to help coagulate the semen in the female reproductive tract, so it will stay. And then we'll see later how the prostate gland releases some fluids to break up the clotting factors, the clotting power of fibrinogen. And it's also going to be a high pH. We'll see a lot of these fluids. A lot of the fluids that the glands release are going to be of a high pH, because if you remember, the female reproductive tract is very acidic, and that's going to be around a pH of 3.5 to 5. And so that's why these need to be very high pH to combat the low pH of the female reproductive tract. And so that's going to help the sperm to survive, because sperm cannot survive in this very acidic environment. So next we're going to talk about the prostate gland. So the prostate gland is about the size of a walnut, and it sits close to the seminal vesicles. It sits under the bladder and in front of the rectum. And that's how, if you get a prostate, for males, if they do a prostate exam at the doctor, the doctor will do a rectal exam to see if they can feel the prostate and any weird masses or anything on it. And so that's because it's so close to the rectum that you can feel it through that space. The prostate gland is also going to add nourishment for the sperm. And the muscles in the prostate are going to contract during orgasm to help push the rest of the semen out of the reproductive tract. It is also going to help coagulate and decoagulate sperm, and so that's that fibrinolysin is going to help to decoagulate the sperm. And so that is because you want, we had the fibrinogen from the seminal vesicles was going to help to keep the sperm in the reproductive tract of the female, and now we're going to decoagulate that sperm so it can spread throughout the female reproductive tract into the uterus, into the fallopian tubes, so that fertilization can happen. The prostate gland is responsible for around 30% of the secretions that are in semen, and it also is going to be a high pH, because remember again, the female reproductive tract is a very low pH, and so we need a high pH for sperm to be able to survive. Next, we're going to talk about the bulbourethral gland. This is approximately the size of a pea, and this is a clear fluid that that when people say pre-ejaculate, that's what they're thinking of. It is also a paired gland. The prostate was the only non-paired gland in the male reproductive tract. It's a basic fluid that will help to neutralize the pH of the female reproductive tract, and it will help to lubricate the urethra of the male and help lubricate the female reproductive tract. It helps to clear urine because sometimes urine can have some acidic waste products we try to get rid of, and so it's going to help clear the urethra so the sperm can survive. And again, and this is only going to be about 5% of what makes up semen. So now here is kind of a rough sketch of where these glands are. So up here you have the seminal vesicles, and they wrap around the back of that bladder kind of. I mean, they're just sit there, and so this is when it's that, there's 2 inches. It's still it's a little larger, some of them, but still kind of small. And then this is where it's the vas deferens right here, and then it's going to connect at the prostatic urethra, and then we're going to travel, and where the secretions of the bulbal urethra gland meet the prostatic urethra. That's when it becomes the membranous urethra. I may have said something different earlier, and I apologize. This is going to be the where the vas deferens meets the prostate gland, and that becomes the prostatic urethra. Whereas when the prostatic urethra meets with the secretions of the bulbourethral gland, that's going to be the membranous urethra, and that continues into the spongy urethra. That's because we have the corpus cavernosum and the corpus sponginosum here, around the spongy urethra. That's because there's that spongy erectile tissue there what is the penis. Here is another rough sketch of what this male reproductive tract looks like. It's going to be you have the paired seminal vesicles or seminal glands, and the paired bulbourethral glands, and you can see there's just a singular prostate gland there, and you can see how we have the prostatic urethra at 1, and then at 2 when we have the membranous urethra, and then 3 we're going to get to that spongy urethra. Next, we're going to talk about some of the supporting cells of the male reproductive tract. So first, we're going to have Leydig cells. These are also called interstitial cells, and they produce testosterone. This testosterone is going to support spermatogenesis, general growth, so that would be, that's going to be bone growth, muscle growth, and general growth in the human body. Then it's also going to be responsible for secondary sex characteristics in males. So things like facial hair or thick facial hair, and the deepening of the voice, and production of sperm, right? And so it's also testosterone is also going to support reproductive drive in males. Now let's see how this is kind of regulated. So it's going to be with some hormones. So first we're going to have gonadotropin releasing hormone, which is released from the hypothalamus. This is going to then stimulate release of the gonadotropins, which this is going to be at the level of the anterior pituitary gland. And this is where we're going to release luteinizing hormone and follicle stimulating hormone. The names don't make much sense in the males, but it makes way more sense in the females. But of course, these hormones are still present in males. So our gonadotropin releasing hormone is going to stimulate luteinizing hormone and follicle stimulating hormone in the anterior pituitary. Then LH is going to be what acts on the Leydig cells. to increase production of testosterone. And this is regulated by when when testosterone levels in the blood are low, and so then gonadotropin releasing hormone will be released because testosterone is low, and we'll start this cycle over again with more luteinizing hormone, more testosterone. And also, I like to think of this as more of just a little memory trick that LH is going to act on the Leydig cells, so L and L go together. So that's why I prefer the term Leydig cells over interstitial cells, but there's also some ideas that we should be going away from cells that are named after people to just kind of what they are to make things more clear anatomically, but I just prefer this way that LH acts on the Leydig cells. So next we're going to talk about the Sertoli cells, or cystinocyte cells, or cystentacular cells, which are going to promote sperm production. And so then they're responsible for the blood testes barrier. The reason why this is important is because sperm is not around when you are when your thymus is developing when you're young, and so let's put this here. Mint. Right, so as your thymus gland grows, well, I guess it doesn't grow, but as your thymus gland trains your T cells and your B cells, you don't have any sperm developed then. And so then if your T cells were to see your sperm cells, there would be an autoimmune response, because it would see the sperm as a non-self cell. So then they would attack, your T cells would attack your sperm cells. So these Sertoli cells help, to have that blood testes barrier so that there's not an autoimmune response. Next, I want to go over some kind of clinical importance of what we just went over. So what's called male menopause, it's where the Leydig cells drop in activity around 40 or 50 years. So since Leydig cells are responsible for testosterone production, that means that's when testosterone kind of drops in men. And so some signs and symptoms of this would be fatigue, decreased muscle mass, depression, anxiety, irritability, insomnia, and loss of reproductive drive. Another clinical aspect that could go along with this is the prostate gland. You can have benign prostatic hyperplasia, and so this would be enlargement of the cells of the prostate. Or actually, that would be hypertrophy, and the hyperplasia is an increase in the number of cells. And I'll just put this here, so hypertrophy, an increase in the size of the cells, but this doesn't have anything to do with that. Okay, so then we see hyperplasia of the prostate, which means that the prostate is going to become a little bit larger, kind of compress on that urethra, and so that can lead to weak stream in men, and obviously that would be trouble urinating. And additionally, it can feel like you maybe can't empty your bladder all the way. Another thing that can come with a prostate is prostate cancer, and this is the second most common form of cancer in males. Next, I want to kind of talk about the hormones like we did earlier. Okay, so these different hormones act on these different cells, And so this is kind of a flow chart of how this works. So you have the gonadotropin releasing hormone that then produces LH and FSH. The LH, right, the L and the L go together, so the LH will act on Leydig cells, and those will then in turn produce testosterone, and testosterone will then be in the blood and also aid in spermatogenesis, which is the creation of sperm. So spermato, and then we have genesis, creation of, so the creation of sperm. Then FSH is going to act on the Sertoli cells to also start spermatogenesis. So something interesting with this, if we were to, let's say we didn't have FSH, but we had LH, right? So then with LH, we act on the Leydig cells and we produce testosterone. So then you will have secondary sex, male sex characteristics. So that deeper voice, the facial hair, and then, but you will not be able to produce sperm because FSH, you also need FSH to produce sperm because of those Sertoli cells. Let's say you had no LH, but you did have FSH, you actually couldn't do either. So you would have no secondary sex characteristics and you would not produce any sperm because you would not be producing testosterone for those secondary sex characteristics or the sperm. So that's just something interesting here about the way the hormones flow and what happens if you have one without the other. Thank you for watching.